Hi students, welcome to your maths class. Now, like in our previous classes we have done the relations and function. What are relations, what are functions. Now the some special type of functions also we have done. Now in today's class we'll do some important questions on relations and functions. So let's start with our first example. So here the first question is, define a function as a set of ordered pairs. Now in our previous class we have already done what are ordered pairs. Now on the basis of an ordered pair you have to define a function. So here is the solution. So let A and B be two non-empty sets. So before starting this example or solution, let us see why I have written let A and B be two non-empty sets. Why they must be non-empty? Because if the sets are empty sets, then we will not can get any ordered pair. So to get an ordered pair, we must have two non-empty sets. So you remember, for ordered pair you must have two non-empty sets. So let A and B be two non-empty sets. A relation from A to B, that is a subset of A cross B. Now what do you mean by this A cross B? This A cross B, see, this concept we have already done in our previous classes. So I will explain. Then if you have any doubt, you can go through the previous videos. Okay. So here it is given that a relation from A to B, a relation from set A to B, that is a subset of A cross B. That means it is a subset of the Cartesian product A and B. Is called a function, or sometimes we may call a function as a mapping also. So always remember, mapping and function are the same thing. So a function from set A to set B if it satisfies the following condition. So what are these conditions? So first condition is, for each A belongs to capital A, that means for every element of the set A, there must exist an element in set B. So that's why it is written that for each small a. See, in our first class itself, I told you that if I write a small letter, English alphabet, it will represent an element, and capital letter will represent a set. So always remember that. So here the first point is, for each small a belongs to capital A, there exists small b which belongs to capital B, such that the ordered pair A, B belongs to F. That means that particular ordered pair belongs to that function F, or that function or that mapping F. And the second point is that ordered pair A, B belongs to F, and if A, C belongs to F, then we can say that B is equals to C. Is it clear? Now see, from these 2 points we will draw one graph. That will be the pictorial representation of a function. Okay, so let's draw the graph. Now see, in this, here I have two sets. One, the left hand side is set A and the right hand side is set B. Now the function is from set A to set B. Okay. Now if you write all the elements of the set A in the first oval or first circle, so according to your first point, for each and every point of set A, you must have an element of set B. Okay. So this is your first point. Now in the second point, suppose you have an element in set A which has two images in set B. That means ordered pair A, B and A, C. Then it implies that B must be equals to C. Okay. So always remember, if an element of the first set has two images, then the images must be same. Or you can say that for a function, one element must have only one image. Okay, so remember this point. One element must have only one image. So this is the second example. Define a function as a correspondence between two sets. So our first example was to define a function as a set of ordered pairs. And in the second example, you have to define a function as a correspondence between two sets. So here the solution is, let A and B be two non-empty sets. So here also I have considered A and B as two non-empty sets. Then a function small f from a set A to the set B is a rule or a method or a correspondence which associates elements of set A to elements of set B, such that here also there are 2 points it has to be satisfied. These 2 points has to be satisfied by the elements. So the first point is, all the elements of set A are associated to the elements in set B. And the second point is, an element of set A is associated to a unique element in set B. Now see, if you read these 2 points carefully, now this point is exactly same as the previous example. In the previous example, you read the first line. For each small a belongs to capital A, there exists small b belongs to capital B, such that ordered pair A, B belongs to capital F. Now in the second example, the first point is, all the elements of set A are associated to elements in set B. So is it clear that both the points are same? Again, if you compare the second point of both the questions, now see, ordered pair A, B belongs to capital F and ordered pair A, C belongs to capital F, is implies that B is equals to C. That means if the first elements are same, then it implies that the second elements are also same. That means A has one and only one image. So in the second example, it is given that an element of set A is associated to a unique element in set B. So are you clear? So definition of function, first as a set of ordered pair, and second one, definition of function as a correspondence between two sets. Okay. Now the third example is, let a function f from R to R, and the function is defined as f of x is equals to thrice x minus 2 when x is less than 0. That means if you take any negative value, the value of that function will be thrice x minus 2. And second one is, if x equals to 0, you will get the value of f of x as 1. And if you choose the value of x greater than 0, that means a positive number, then the value of f of x will be 4x plus 1. Now based on this definition, you have to find the value of f of 1, f of minus 1, f of 0 and f of 2. So let's see how to solve this type of questions. Now it is given that, let us find, given, what is given? The definition of f of x is given. Now you have to find the value of f of 1. Now if you notice f of 1, 1 is a what type of number? Yes, 1 is a positive number. So in these three conditions, f of 1 will lie in the third condition. That means x is greater than 0. Now if x is greater than 0, so our value of f of x is 4x plus 1. Is it clear? Now, so let us, when x is greater than 0, f of x is equals to 4x plus 1. Now the value, that means the value of x is 1. So in place of 1, I will write f of 1 is equals to 4 into 1 plus 1. So if you solve this, you will get 4 plus 1 is equals to 5. So from the definition of that particular function, I will get the value of f of 1 is equals to 5. Next, to find the value of f of minus 1. Now minus 1 is a negative number. So in that particular definition, it is given that when x is less than 0, the definition of f of x is thrice x minus 2. Now substitute the value of x as minus 1. Why? Because we have taken the value of x. See, the particular values I have to find f of 1, f of minus 1. Now 1 is less than 0. So that's why I have taken this case. So f of x is equals to minus 3x minus 2 for x less than 0. So substituting the value of x as minus 1 in this value, I will get 3 into minus 1 minus 2 is equals to minus 3 minus 2 is equals to minus 5. That means for x equals to minus 1, f of x is equals to minus 5. Next, I have to find f of 0. Now see this definition. When x equals to 0, f of x is equals to 1. So here I have written when x equals to 0, f of x is equals to 1. So substituting x equals to 0 in the above equation, we will get f of 0 is equals to 1. Okay. And last one is we have to find the value of f of 2. Now f of 2, that means x is equals to 2. When x is greater than 0, our value is 4x plus 1. As 2 is greater than 0, I have to choose this third condition, third equation. So here I have written that when x is greater than 0, f of x is equals to 4x plus 1. Now substituting x equals to 2 in the above equation, we will get f of 2 is equals to 4 into 2 plus 1, and if you multiply 4 and 2, you will get 8. So 8 plus 1 is equals to 9. So the solution is, that means the value of f of 1 is equals to 5. We have already calculated. Similarly, we have calculated for f of minus 1, which is equals to minus 5. F of 0 is equals to 1. And lastly, we have calculated f of 2, which is equals to 9. So students, these are different types of relations and functions. So I have explained, I have discussed some types of questions. So if you have any question or if you have any doubt in these questions, we will discuss. Okay, so I will stop here for today. So next class we will do some more important topics. So thank you for today.